on to our last panel of the day, which is, well, I'm not going to say last, but certainly not least. And now we're going to be focusing very much on the technology. So obviously with Michael, we talked a little bit about AI. I did that earlier as well with some of the discussions with Devrim and the significance of AI and machine learning, IoT. So we're going to deep dive into that a little bit onto this panel, which I think we probably needed to do as a conclusion to the day. So it's moderated by the absolutely brilliant Philip Steele, who was on a panel earlier, who's the Future Technologies Evangelist for Octopus Energy. So the panel is called the AI Machine Learning and IoT Revolution. So how to build greater adaptability and resilience in our network. So over to you, Philip.
Hi, Adam. That's a great intro. Thank you very much. I mean, fascinating to talk about digital twins. I don't have a digital twin, and I don't have a digital twin in my house, but it could be quite interesting to have one. Talking of houses, if you're watching this, you may think I'm in a house. I kind of am, but if I just shift my screen a little, you'll notice there's not the usual street scene outside. This is a laboratory. This is our R&D research centre in the centre of Slough, where we're experimenting with heat pumps and training engineers and so on. If I can have the panelists to the stage, and I can introduce the panelists to this session. So, as you said, Adam, AI, machine learning, and IoT revolution. I look after lots of R&D with this this title that you mentioned, the somewhat fancy title of Future Technologies Evangelist. But that means my role is exploring and experimenting a lot of really interesting tech in how the energy system works. I think as we see the grid change to being an all renewable grid, we're at about 40% today, it's 25% solar actually. Energy becomes very intermittent and distributed and variable. And at the same time, we're doubling our energy consumption as we all install heat pumps and drive electric vehicles and so on. So there becomes a role for how is that all managed. And I guess AI/machine learning, and that is obviously AI IoT world of things, starts to play into all of that. I'm not a massive fan of the term AI, artificial intelligence. It's all too sciencey fiction, but of course a lot of it is built on machine learning and applying statistics and modelling and so on. So I'm hoping to have a really good conversation with the panelists here. If I can introduce each panelist to give a quick 1-minute intro to themselves and your role. So we'll start with Euan Norris first, please. No, Euan. I think you may be on mute.
I'm not.
No, you're good. You're good. It's working. There's a delay.
Yeah. So good afternoon, everyone. My name's Euan Norris, Head of Smart Cities at Scottish Power. My role is to support, that decarbonisation journey of our customers, large organisations, obviously cities, and from conception to what's the right thing to do, right through to the delivery. So I'm really looking forward to contributing to the panel today, and obviously recognise the importance of automation, AI, and how it will shape our energy future. Thank you.
Brilliant. Thank you, Euan. Going on down my list, next we have Ronald.
Hey, good afternoon. Hope you can all hear me. My name is Ronald Starreveld. I'm part of the Salesforce team. My role is a distinguished enterprise architect, helping out the TSO, the DSOs, and the energy suppliers in the UK and Ireland to help them with their business strategy translated into a technology strategy. And obviously things like machine learning, AI, and IoT form part of that ambition to get to net zero cloud that is extremely important.
Great, thank you, Ronald. Next up, Thierry.
Good afternoon, everybody. I'm a digital lead in Hitachi Energy, in particular the digital lead for grid integration, which is one of the BUs in Hitachi Energy. We deliver products like power semiconductors that go into electrical converter systems of various nature, up to delivering very high complex, high power, high voltage systems that, for example, connect offshore wind parks to the electricity grids.
Okay, great, thank you. Next, Leonardo.
Yeah. Good morning, everybody. I'm Leonardo Ambrosi. I'm the Director for Innovation and Digital Transformation even if I see there is a typo here. But actually, I'm coming from an experience in technology companies, and now in the last month, I'm bringing Italgas, which is one of the major gas distributors in Europe, and innovate them to challenge the future regarding decarbonization through innovation, digitalization, and AI, of course.
Great, thank you, Leonardo. And finally, Alex.
Afternoon, folks. So Alex Mahon, Head of Analytics at UK Power Networks. Philip touched on the fact of the difference between AI and ML. So I'm a large advocate for machine learning. We do a lot of things across all of the KPIs for the business. And I like to think I have a dream job as a result, because basically wherever I can see value, I'm allowed to go and play.
Excellent. Yes, that's probably one of the challenges. Actually, is the amount of data and information coming out from IoT devices and systems and things. Is actually, where do you start and what do you actually look at? But the first bullet on our list here is how AI and machine learning facilitate the energy transition. So as I was saying at the intro bit, we're in this transition world of doubling our energy consumption and moving to all of the renewable generation and what that actually means. And that has an impact on forecasting and then also actually how you distribute that energy around the grid as well. I don't know if one of you want to start off with a kind of a response to that particular point, or I shall pick on somebody and ask for a reply. Maybe Euan, do you want to give a first response on that point?
Yeah, thank you. So obviously, as it's been highlighted already, we are now into a world where the power sector is going to be critical to society as we electrify more of our heat transport needs. From a networks point of view, power flow is now very divested, if you like, from that traditional centralized plant, and the number of devices that are coming onto the network is just exploding, and that's we're talking in the traditional sense here, even just the number of generators supplying power to the grid. Now that's went tenfold, and that's going to be huge numbers, and the visibility of that. Even today, the network operators are probably still grappling with to get visibility of that, understand how that contributes to the energy flows, and then you've got the added increase in demand technologies, low carbon tech. So if we don't use artificial intelligence, machine learning to operate, manage that, coordinate that, then we will be in a state of flux. So it's critical. It's critical to our future energy system. It's critical to how we use, produce, consume energy, and how we plan for the future, our growth and requirements for that electrification of and decarbonisation of society.
Yeah, I think as well what Euan's... I just wanted to follow up what Euan mentioned around from what it means from a demand perspective. If you look at it from an energy supplier perspective, so coming through from the demand, I think things will change as well. I think what we see right now is this half-hourly settlement, and as a result, energy suppliers are much more finding ways of actually driving this as a very personalized pricing billing. So the next logical step is actually that personalized forecasting, as we all have different needs and different needs of how we consume the electricity. It's about using all that historical smart meter data that is available by the energy suppliers and combining that with the machine learning to get a much more personalized forecast that we then can aggregate on a geographical level that becomes very meaningful in forecasting the actual data moving forward. And this is key, I think, in what we just talked about. There's so much data that data needs to be shared. So the data that exists within the energy suppliers need to then be shared with the distribution companies to assist with the management of the smart grid, as Ian was mentioning earlier.
Interesting, actually. You said there a personalized tariff. I've not come across the idea of a personalized tariff before. When at Octopus, we do all sorts of smart tariffs like Agile and Go and Intelligent Octopus and so on, but that kind of takes it to another level.
Yeah, that is to do with the fact that you see that in the big IMC world, where we have consumption that is very personalized as in bespoke pricing. But I can see that, Philip, you and I might be consuming the same amount of energy on a daily basis, on a monthly basis. But the way we actually consume that data the electricity is very different. And therefore that should be reflected back in that flexibility around a personalized price that actually works for you. So the actual consumption over kilowatt hours per month might be the same, but the price that you and I will be paying will be very vastly different depending on the consumption, because it should be reflective of the actual energy that is available at that given time.
I'm digesting that thought because it is very interesting. Go on, Alex.
I find this super interesting because forecasting and kind of getting to a world where you can have individualized tariffs and that kind of thing. I think from the research that came out in the ED2 submissions, the latest price controls, is that about a quarter or a third of the UK population really struggle with any kind of technology at all. And so ultimately, all of these companies, barring like the generators, are pretty much regulated. So they've got to have a guaranteed amount of revenue coming into them. So if we start allowing some aspects of the population to have these kind of bespoke tariffs without supporting the other ones, then there's a real risk that actually those who are most vulnerable are going to end up paying more than anyone else.
That's true.
It's not necessarily saying that the other ones, the existing tariffs, don't exist anymore. They will continue to exist. It's about those innovators and people that are really interested to come up with something, and they should be rewarded of installing their home battery. They should be rewarded for having solar panels on their roofs, and then trying to find and actually making it sense for them to use it from a personal perspective, and using machine learning of actually how to predict that in the future. It becomes a paramount building block in how we come to a zero carbon overall achievement of the objectives that are set by the government.
Yep. Maybe there's a difference between, coming to your point, Alex, about engaging those that aren't technical savvy. There's a difference between the price that you get and the technology, and whether you're responsible for the technology. So I've seen housing providers, so for example, Together Housing in Lancashire, they used ERDF funding to install solar battery systems on 250 homes or so, and now we're working out the commercial model to go beyond that. And they're already looking at being a kind of a VPP, if you like, for the local grid there, because they've got, it's probably several megawatts of battery capability as well as the solar generation on those properties. But those tenants in there, they are the right sort of tenants that will get the most benefit from solar generation, and without needing to actually be aware of the technology. It's in the loft space that they never go into, and it's a managed service for them, if you like.
Yeah, I think that you raise a very important point there, Philip. Distinction between the time of use and something that you interface with if you're tech savvy, and using that machine learning, using that intelligence to actually optimize for the customer who may not get the same benefits, or might not be at the same stage of their journey in terms of interaction. Just to go back to Alex's point, we have to, we talk about adjusting, and again, that's ensuring that we can achieve what we need to do in decarbonisation, but it's fair and equitable, and those who can benefit are able to benefit, but equally so nobody's left behind. And again, as we invest in our system, invest in our networks, it's very important that we have that at the forefront. Energy is a key component, and it's got to be made available to everybody, at least have an equal opportunity to access it. And machine learning and optimization is going to be really important to support some of it.
Yep. Maybe we should hear from Thierry. Oh, sorry, Alex, go on. I interrupted.
I was just going to say, I think that's where AI and ML really has a role to play, because actually, all the companies are putting in hundreds of millions of pounds for different things, but actually there are smarter ways to do a lot of this stuff. We don't need to put in necessarily sensors on every substation. You don't need to put in more copper. You just need to work out where is the utilization going to be and where is the capacity remaining, and then how do we link those things up better? Sorry.
Maybe we can hear from Thierry, because Thierry, you're at Hitachi. Yeah, sure. You're making these appliances. So we're talking about at this level, right? We're going to learn a lot from all the data that's coming through these machines, but you've got to make the machines.
Yes. Well, if you look at an energy system level, I believe that machine learning is an interesting instrument to implement the automation layer that will be needed to achieve resilience in that system. We are more and more moving towards what we call a VUCA world, a world which is volatile, which is very uncertain, has lots of complexity, and is ambiguous. And in the energy system, this is certainly the case. We will move from the traditional electrical distribution system to a combination of that legacy system with electrification caused by mobility. We will have microgrids. We'll have integration with large-scale renewables. And how do you manage this interaction of those subsystems? Well, we will need some level of automation in order to manage that diversity. And that's where ML helps to implement that automation level. And okay, we talked about various dimensions there as well now, from energy markets till the assets that are in the field, which comprise the full energy system.
Leonardo.
Yeah, I just wanted to bring you a slightly different vision on that because I'm working for a gas distribution company. But almost the entire my career I spent in the electricity sector, right? So I was involved in several projects, initiatives around microgrids, virtual power plant, energy communities, and so. And it's actually very interesting to analyze this from the gas perspective, because a lot of energy, or at least in Italy, half of the energy is generated using gas. And a lot of industries and private homes use gas for that. And the gas sector is facing a very big challenge, because to decarbonize the gas sector is very hard. And this is our goal. So, I mean, to distribute in our network renewable gases. And what happens when you do that? It happens that, first of all, what we already experienced in the smart grid, so different flow of gas, because the gas does not come anymore from Russia, but it comes from local producer, which is H2, hydrogen, or biomethane, and so on. So the flow of the gas in the grid really is changing direction. We're not talking about electrons, but about molecules. But the concept is more or less the same. And moreover, we have the complexity of the quality of the gas, because gas might have different qualities. And we need to supply it with the same quality our customers, industries, or private households. And specifically, when we talk about energy communities, there we see a lot of integration between electricity and gas distribution. And why AI? Because we need to manage this transition in a way where we are able to analyze precisely the energy that we are transferring. Every gas has a different content of energy. So we need to know precisely where the gas is going to. And the only way to do that is to, in some way, create a kind of digital twin of the network and know exactly how the gas are dispatched in the network itself. And then to analyze all the data to predict how the gas generation and dispatching will be managed will be crucial to balance and be able to correctly, properly transmit, dispatch the gases. So for us, AI, we are starting from traditional aspect like optimizing the operation, predicting some faults, but in the future will be guarantee the decarbonization of the sector in order that we know exactly which gas, the quality, and how we need to interact with the electricity sector. Because, for instance, take hydrogen. Hydrogen is a great technology that you can use as a gas itself, or you can use as a long-term storage as well to balance the energy grid, where electrical batteries might not serve the scope, right? So we see a lot of interaction, and the capability to balance, forecast, and measure the quality of the gas through AI for us is critical. I mean, it's the key enabler of this transition, which is quite hard for the gas sector because of the traditional appliances, the usage in the industries mainly of the gas. So this is the challenge that we see and that we are tackling today.
That's really interesting, actually, because I must admit, most of our focus is actually on electricity because of the renewable generation nature, and it's not a fossil fuel. But it's interesting, actually, you do have the same sorts of challenges, but it's a different set of challenges around that, the quality and the where the gas is all coming from and how you manage that grid to be able to balance all that. I must admit, I've not actually appreciated that side until you've actually described it in a little bit more detail there. So, just looking back at our list of bullets, we'll move on to the second one. AI and predictive maintenance, managing the use of surrogate modeling. I don't know what surrogate modeling means, and I don't want to have a take a guess. Can somebody give a definition of what surrogate modeling means with our agenda that we've been given? No takers. I'll have to pick on somebody. Thierry, what's surrogate modeling to you?
Let's take an example. Let's take a lifecycle management of assets. If you want to understand how or compute how the failure rate is of an asset, what is the risk related to an asset, you have various approaches of modeling. And one would be to use, let's say, the mechanisms through which you model by mathematical formulas the physical or electrical or chemical laws that are ongoing over the life over that asset. Another way to approach would be, okay, we take a machine learning approach where basically you're codifying the parameters in that machine system that govern that asset and how it evolves over time. And then you are able to build on top of that layer a mechanism that predicts when the systems are failing. So we have there two ways of modeling, and you could either use one or the other for assessing the behavior of your network in terms of life cycle, but you could also have a combination or a mix of that. And I would understand a surrogate model, kind of mixed model based on physical laws in combination with machine learning, which are more maybe mathematical driven modeling techniques.
Yep. Anybody, anything else to add to surrogate modeling?
I think that's a good definition. I think as we get more information, I think this ability to, like Thierry mentioned, about estimate better in that given geography and given that particular flow, given that particular load that is on those assets, is something that is massively important for a lot of the transmission and distribution companies in order to be able then to say, okay, we can go now to a much more of a predictive maintenance model, where if we send out an engineer to a particular area and we know there's an asset within that same site that is going to fail in the next month, to do that upfront and proactive is something that all distribution and transmission companies are looking for in order to be able to drive down the cost and, more importantly, to avoid outages in the future.
So there's a difference between, well, there's a kind of two parts to AI in that sense. It's applying that to that predictive maintenance, but I think, as Alex, you were saying earlier on, you may not need to actually monitor everything in terms of the performance of, or not the performance, but the capacity and throughput of appliances. There's kind of two different purposes for AI in that context, I think, right? Sorry, I didn't aim that question at anyone in particular, either Ronald or Alex.
Yeah, so I guess the key thing with all of this stuff is that at the end of the day, it doesn't matter how good your data is, it doesn't matter how much of it you've got, your model is only ever going to be a model. It's never going to be right. And there's sometimes a misconception when people are like, I built a model and it's 90% accurate. It's 90% accurate against the validation data set that you've used. It's not 90% accurate against the real world. And so I think a lot of stuff, like if I think of machine learning terms, surrogate modeling is normally a way for you to basically create a data set to test an outcome. So if you don't have a defined data set already that says this is what happened in these variable situations, then you can use it to basically create the data set and train the model on that. So they sometimes use it in healthcare, and they've got really small sample studies. But it's something that it's not great, because actually you're better off using real world data when you can. But I think most people don't recognize that actually models are never going to be 100% accurate. So you're always going to need humans or sensors on the network somewhere to actually test some of this stuff.
Yep.
It's a very important point. It's a very important point that Alex mentioned about this the IoT type of devices, some mechanism to actually hold back the real information. As we get more and more information available, then we can optimize and the algorithms that we have in machine learning in order to predict what will happen. If you look into maybe some of the other industries like manufacturing, where they have much more data available and they're much more on top, I think this is just the start of the journey. It's this tsunami of data that we'll get as part of the electricity and the gas networks that we have. As we're getting more information, those models will be improving and getting better.
Is half our data enough? Like smart meters, we have half our data and we do billing on half our data. Is that enough for that sort of thing or not?
No, I don't. I think there's a number of things are required. So if you look at the networks themselves, we're talking about, artificial intelligence, machine learning, but we're actually at the very, very start of that journey, given where, our network has been. So we're putting all these myriad of devices and power flows are going in different directions onto a network that was very, up until a few years ago in my working life, if you like, was not active, and it's going to get a hell of a lot, more active going forward. So there's going to be parallel activity. So from a network, they'll be building up that data, as Ronald just said. From a customer point of view, how we interact and how we actually use power, as you mentioned earlier on, has been mentioned. We're all changing, looking at, half-hourly data, looking at what we've put in, smart metering, has that really changed a lot of behaviour? Probably not, because it's still based on the human human element. But actually it will, as we get more information and we start to integrate electric vehicles in our homes. And you mentioned earlier on, Philip, heat pumps. There's intelligence coming into our homes that the network operator will never see, even the supplier will never see in some instances. So there's a whole things that that data is still quite static. So half hour is quite a long time, even in the lifetime of a network operator. You really want it down to minutes, 5-10 minutes, and you're moving. So you're trying to get closer to real time as possible, but it's a start. It's definitely a start. I think we'll gradually creep in as we get more devices and more electrification. And as mentioned earlier on by Leonardo, that interaction with the gas network as well. How do those things face off to one another? That's going to be a really important conundrum to solve as we go forward. So it's a start. It's not enough, and I think there's a whole host of different elements of the energy system that needs to start, on this journey to get real data, intelligence, and understand how it informs future decision making.
I think Thierry, you're trying to jump in?
Yes, it was mentioned accuracy with respect to surrogate modeling as one of parameter, accuracy or level of detail, but it is also choosing the right model in view of the problem that one wants to address. Is it take an asset in an electricity network? Is it the purpose to model the way electricity flows in and out of that function? Or is it, for example, the target to build a model that predicts the lifetime of the system? This requires complete different models. If you want to compute the remaining useful lives, you have a complete different model to build versus showing the energy flow through the system. So you need to build models for the purpose of the problem.
Yeah, I just wanted to pick up what you were saying before, just make an example, because I briefly said that before. I mean, we are building a kind of digital twin of the network, but the aim is not to simulate physically the network. It's nearly impossible. We do sometimes when you need to build new stuff from scratch. But now, since we will have this, let me say, instability in the network that we will need to manage, we need to react very quick, and the simulation of the network based on the data is crucial to provide such, let's say, resilience in the network. And so just to make an example, we have a lot of smart meters. In the gas, it's a bit more complex, the task, because the meters are not powered with electricity. They run on battery. And the data of the smart meter itself are not enough. So we need to combine those data with the data that we acquire with sensor along the network to be able to understand how the network behaves, where we lose gas or where the gas is steady, where we need to, manage in a different way the pressure of the network because the gas is not flowing in the proper manner and so on. So this is an example where the data, and as Alex was saying before, to manage all the data, I mean, we are looking to have almost the most complete data set here. It's crucial for us to tackle this kind of problem. And the smart meter itself are not enough, especially in the gas industry. We get a lot of data, but not eventually with the granularity that we need. So we need to combine this data with network data and make a kind of black box or surrogate modeling of the network for the purpose to properly manage the different flows of gas and increase efficiency. I mean, leakages and reduce the gas death and so on.
Mm-hmm.
I must admit, I get shouted at quite a lot because I always refer UK power networks to the water sector. And I say, actually, we think we're so far ahead. But I've come from the water sector like a few years ago now. And when I look at that, I look at condition-based monitoring, I look at smart metering, they're ahead of us. And actually, there's a lot we can learn from them. Like we're talking about smart metering data isn't enough. And I agree, like looking at smart metering data, it's not enough. But actually what you can do is the equivalent of a water balance where you do a top-down and a bottom-up calculation. And actually that gets you even further than either of those individually. So I think there's a lot we can learn from other sectors that are already ahead of us in some of this space.
That's interesting, yeah, true. I haven't looked at the water sector at all, so I haven't got any knowledge of how they're doing their metering, but you should. Actually, Alex, whilst you're there, I've got another question for you and the others that are related to power networks. We've launched all sorts of smart tariffs like Go, which has a cheap period between half midnight and 4:30, and the Go Faster, which has a different start time for 4 or 5 hours for charging EVs and things. And the Agile tariff is priced differently in each half hour of the day, according to the wholesale market. And then our Intelligent Octopus tariff, which is taking wholesale price signals and saying now's a good time to charge a car, and so on. And so we're working in a half-hour basis, and things are connected. IoT, talking IoT, are connected to those tariffs, and then saying, right, I'm going to charge the car at precisely 9:30 in the evening. What sort of impact does that have on the grid and monitoring things and trying to react? Because we're kind of artificially affecting the grid rather than renewable energy. The wind drops, the sun goes in a little bit, and so on. Do you see that impact, Alex, of smart tariffs on the grid?
So I confess, I think if I'm right, you've got what 20,000 or 28,000 customers signed up on Go. Yep. Yeah, and they're spread across the whole country. So for us, we've got just in UKPN 8 million households. So it's because it's so geographically dispersed, like it probably wouldn't register enough for us to see that kind of change in demand.
Each EV charger is like a 7 kilowatt load or something, compared to a background load of less than the kilowatt. It's a sudden chunk of energy that's swallowed up.
Yeah, I mean, it would depend. Like if it's it's a pole-mounted transformer with only 4 properties connected, so you've got a really small pool to go from, then you suddenly start seeing these random, semi-random spikes appearing at night, then yes, absolutely, we'd see it. But I think otherwise, like it's probably, at the moment, there's probably not enough of an impact for us to do it. I think you guys have got a really good thing called the Centre for Net Zero, is it, with Lucy Yu?
Yep. Mm-hmm. Lucy, yeah.
Yep. They're doing something, I think they've developed something called the Faraday tool or something that's really interesting, because they're actually looking at that data to see, actually, can we identify where the distributed energy resources are? So can we identify houses with multiple things like multiple EVs or batteries or other stuff? And that, like, the potential for that is really cool. And if they're able to get those algorithms and scripts out, then actually that's something I think all DNOs and probably the transmission operators at some stage, once the penetration is big enough, will benefit from.
Yep. I missed her opening session at the beginning of today. If she covered it or not, did anybody catch it? No. Okay. No problem.
Regarding what the supplier is incentivizing their customer to do in terms of energy use based in the wholesale market. But from Alex's point of view in the network, they still have to deal with the physical. So as you say, at the moment, because of the low penetration of EVs and heat pumps and the sporadic nature across country, there's probably limited insight or limited impact. But actually, once you get those clustering effects where you've got the incentive from the supplier to use energy at a certain time because the wholesale market is prices are good, but actually the physical network's a physical network, and the UKPN example or the DNO example, they might be incentivizing the customer to turn off So, you know, that it's trying to get that hierarchy of control, you know, and it's not going to happen for a period of time, but it will in some instances, you know, as we start to get greater penetration of low carbon tech. And, you know, there's a number of incentives on customers to use, going back to probably Ronald's point about the that individual price, you know, that becomes more apparent when there's more people using energy, because you're agile and the tariff is very much focused on a time period, but actually I might not want, you know, my lifestyle might mean that I don't charge my car at that time every day, and then if everybody car at that time, well, that's going to be the most expensive period going forward. So it's just, you know, the world's going to change, and it's getting that visibility, you know, that will be that.
But it's so tempting with AI and machine learning and so on to then put an API on it and send a signal out to appliances, and then you start to get into a discussion about the randomization element of it. And I've discussed with customers what the time is on their smart meter, and they're billing on one time, and then the smart controls are being applied on perhaps GMT or UTC or BST or whatever, and then you start to get into a conversation. Well, you sent the signal at GMT to charge my car, but the meter's actually running 3 minutes early, so I got billed the first 3 minutes at the higher tariff. But then you need to do that because we need some level of randomization. So in the future, we don't just start saying, right, all heat pumps start generating hot water, or all cars all start to charge now. Hypothetically, even logistic, you know, realistically, it's going to become a challenge doing this.
Definitely.
Yeah, very much so. And think about this. When we currently talk about a consumer and an energy supplier and the DNOs, but add to that people that own other assets that either can consume electricity or can put back electricity. So people like the aggregators, like the people that have DMRMS, people that have RES devices, VPPs, all these other interested parties that are suddenly can influence your load and your management of your network, that can help you or can hinder you. And I think for me, going back to the point of we've got lots of information available, but it's about sharing that information with all the other people in a real time as much as we can, machine to machine, using machine learning and AI capability, intelligence to make those decisions. For me, is paramount in order to be able to deal with all those, because it's already complex. Add all those other layers to it, and this distributed energy and generation and storage facilities, that makes it even far more complex.
Yep. I don't want to tease Alex on this. Alex, you're saying you've got a substation, it can cope, so great, the EVs start to charge. But I think actually between all of us, we're all kind of like, this is happening and we need it. And is this how the energy system has got to work in the future? But our next bullet in our list there is incentivizing the supply chain, how policy frameworks and business models can help facilitate data sharing and encourage the innovation in this space. And you have, is it silos? Because you've got us as the energy supplier, what's going on with the Internet Zero, the tariffs that we're doing, and you've got the distribution networks, and you've got to look after that network layer, and then you've got the transmission and the generation side of things. And where are the connection points for all of that to work and be aware of each other?
I guess that's why the regulators. I'll go for that. Yeah. I guess that's why the regulators put in around the DSO. Like, that's the whole reason that they've said, actually, guys, have a think about this, because they recognise there's a gap in the value chain. And actually, the DSO theoretically could fill some of it. But I think there's also discussions at the moment of, would you have a national level one? So in the same way that for transmission, the spin out, is it FSO, the Future System Operator, something like that? You know, the DSO theoretically could fill some of those gaps, but it all comes down to, as you say, how do you incentivize the supply chain? If suppliers are incentivizing customers to use certain time of use tariffs, does the DSO then liaise between a supplier and a DNO for the DNO to pay the supplier to not have that tariff available? Like, it's all about the business models, and it's getting into a much more commercial world than an engineering world, I think.
Yeah, I think you raise a very good point there, Alex. It's a network operator has obviously got a physical asset, but it's becoming an IT operator very quickly because it will need a lot of that to make the physical happen. And I think what you mentioned there in terms of the DSO and a national versus I think the whole point of having that local DSO is a valuable thing, because one of the issues that National Grid have at the moment is that they probably don't have the visibility right down into that low voltage layer, that where most of the action is. And Philip just talked about the incentivization of EVs, heat pumps. It's all at the LV network layer, and there needs to be that integration and openness in terms of data sharing, both ways, both top down and bottom up, to actually make the energy system work effectively, so that we're not taking the right intended decisions, but they have consequences for various actors within the industry. So I think open protocols, I think the digitalization strategies that the DNOs are starting to implement as part of ED2 are going to be vital, but then making that available to suppliers, to energy users on a consistent basis throughout the UK, and then those decisions can be taken openly. And I think from manufacturers and people that are bringing forward products, we've got to have open protocols. We've got to have, the ability for, we talked earlier in this session about how it's important that people are not left behind. Well, you can't ring fence and you can't tie people in. You've got to give them choice. But when they exercise that choice, they can't then be burdened by having to change, a billing system or change how they interact with the assets in their home. There has to be open. So I think some legislation.
And I think you're absolutely right, Euan. And then I think something that Philip already mentioned about, this is some discussion that I had a couple of months ago with one of the energy suppliers around social housing. So look at social housing and the problems that we have in fuel poverty that we have in that particular area. By actually installing some sort of local generation and battery storage or other ways of storage in those local housing estates, actually using their property in a very passive way from the actual tenants themselves, but actually use it by the energy supplier or by someone else who's interested, by creating this demand response or VPP capabilities. The savings can then be applied directly to the tenants who live in those premises on those social housing. Therefore, also addressing one of the major critical areas that we have in the energy sector is around fuel poverty. And by combining those two, I think there's actually a way forward if we put actually our minds together.
What you're talking
Maybe
about.
there is
Sorry, go on, Thierry. Go.
Yeah. Maybe there is another dimension linked to supply chain. Grid systems, electricity systems, or gas systems can fail. So that means that a port or a subsystem fails, and that means either it must be repaired or it must be replaced. So linked to supply chain, sourcing, and logistics, the question to be resolved is, what do I do to make sure that the risk of having an overall failure is minimized? And there one has to take decisions about how do you have your parts of the system that fail as spares available, locally or sourced from somewhere, because depending on where this these spare parts are, it will impact the time that it takes to restore the network. And that's also an optimization problem where machine learning can help.
Yeah.
Just
interesting on.
Go.
Sorry. Yeah, I just wanted to bring you. Just wanted to bring you a slightly different vision on the topic, because we are a DSO. We are strongly regulated as all the DSOs, and our job is to favor the distribution of gas or electricity and help the traders to sell more, right? So we are engaging in a tough discussion with the regulator, because we as DSO, we know very well the territory, the area, the cities, because we have, we are monopolists there, right? So we know exactly how the different customers are behaving. While the traders, they might have customers here and there, quite scattered, no, in the country. So we would like to share our data to build better services for the traders, to help them to help the customer to manage, the energy in a more efficient way, help them to propose better energy contracts and so on. And this is quite tough because being as a regulated company, it's not easy to build services, share the data with the traders that we need to agree with us how to do that. And of course, there are multiple TSOs and multiple traders. So this is a simple topic, but which is kind of difficult to bring ahead because regulation tells you that the meter data you cannot share in some way. We only have to send this kind of meter data to the trader. You need to make sure that you not favor some traders despite the others. So the openness of the data and enabling all the parties in the value chain to share the data to offer best service to the end customer is key. And sometimes the regulation doesn't help. And this is where we need to push strongly and change the system and help the regulators to adapt to it.
I think just one more point on this. The supply chain can really help here. Like if you look at the ED2 plans, most of the distribution networks have put in around 20 to 30 million pounds per company for LV visibility and sensors. And the average cost for those sensors is somewhere around 1,500 to £2,000 a pop in terms of the sensor and the installation. So if the supply chain is able to do anything to bring the cost of that down to get to a 50 quid throwaway sensor that actually is cheaper just to bin it than it is to buy a new one. I know that's, don't get me wrong, there are some recycling and all that kind of implication to think through, but a cheaper sensor that still has connectivity that doesn't cost that much money, you're going to get a lot more data available because none of the networks have 100% LV visibility, none of them. Hence why they've all put in these massive sums for ED2.
That's really interesting. No, I won't show a device that I have here. You might have seen on Twitter that we started to experiment with some smart devices, but these are more about smart meter data at kind of 10-second interval. Very prototype stage at the moment. At an extremely competitive price point, but probably not suitable for the kind of grid monitoring that you're after. I guess there's a reason why those devices are £1,500 at the moment. I want to talk about local energy as well, because we talked kind of about local constraints and things, what Ronald, you were saying, and Alex, you were saying. And there's tariffs that we've done, like the fan club tariff, where customers living near a wind generator get 20% or 50% discount according to how strong the wind is, as a way of saying, right, we don't want to start curtailing wind generation. Let's soak that up and incentivize and encourage customers to use it and do the right thing for the grid. But if you start to, it goes back to some of the beginning of the conversations about AI and the tech and engagement and things. You start to end up with a bit of a postcode lottery over who gets the benefit of those tariffs and things, and trying to make sure it's inclusive of customers that need reasonable energy prices and things. It's kind of leads on to the next bullet we've got, which is around the balancing of supply and demand. And we're doing that with the fan club, but we're not doing it with the kind of right frameworks and policy to recognise that we are using the grid less by trying to consume energy locally, but we are actually using it to effectively try and balance supply and demand. But it's a local thing, and I think we're going to see that requirement being more local, and maybe that's where AI will have a really big benefit, because we're going to be able to better balance that supply and demand. Who wants to respond? Euan, you ready?
Yeah, no, I think there has obviously already been progress in that area in terms of local generation, local supply. UKPN, SP Energy Networks, all the DNOs, SSE have all started to look at flexible connections, and all that is around balancing that local demand with local generation. And I think, but again, it goes back to the points we've been talking. It's taking a section of the network or the energy system, i.e. the physical constraint, and trying to, you know, marry that up with the local demand. But what you're talking about, Philip, is taking it to the next level in terms of bringing in the supplier in there and that interface. So there's been an engagement between the generator and, you know, potentially a point of demand to flex that demand.
At a business level, that happens to air conditioning systems in warehouses and things. Yeah.
Exactly. So, but there's no any linkage to the actual physical supply contract between the customer and the supplier, and how that. So I think, again, that probably builds from what we've just been discussing around the role of the DSO, the importance of that local DSO, being able to interface with the supply businesses and the aggregators and all the different actors. And actually, you know, local energy and demand consumption is good. And if you've got flexible assets on there that can accommodate it, that's really that's positive in terms of managing local constraints, but also making sure that you don't need, well, you'll always need reinforcement in the network, but it's not as critical because you're not trying to power up and down the, you know, beyond the local area. So I think it's certainly gotten we've already started in terms of networks, you know, through network management. I think it needs to take that next leap to bring in all the different actors. And I know there's, you know, ourselves are looking at how does the actual customer in the home, the domestic customer with their asset, start to interact and provide that service to the network as well. So, you know, automation, control, visibility, transparency, it's all the key things that we've been talking about throughout this session that need. And I think one thing we haven't touched on here is the security element, cyber security as well, and the importance of that. To everybody.
Oh yeah, that's a complete other panel topic, isn't it? Security of IoT devices, and security of the grid, and.
I guess for me, when I think of it as a challenge, if I think of like AI and balancing supply and demand, I think of short term and long term. And a lot of what we talk about is the short term stuff. And that's where people are like, oh, smart meters will be amazing. And I think we've had a good discussion on whether 30-minute data is enough for that. But if you think about it, the sector as a whole is really good at doing individual assets, if they've got the monitors on them, and forecasting what will happen in the future on an individual asset level. They're also really good at long-term forecasting because they'll work it on averages. They'll say, on average, in 25 years, I know I'll need to replace 5,000 substations at this cost. Please, going to have this much money. But what's really, really hard, and this is the thing we're struggling with as an industry, is short-term forecasting of 24 to 48 to 72 hours. Because that's where flexibility, that's where aggregators and everything else, that's where those markets and that money is going to come in. And actually, that is the hardest thing, because 30-minute data isn't really enough to be able to then, with any kind of super degree of confidence, give somebody a commercial deal that says, can you turn on in the next hour, please, because we're desperately going to need it. And so actually, it's that short-term forecasting piece which is going to be the real challenge in supply and demand balancing. And the models will improve, they'll get better over time. But I think the challenge in the short term, in the next couple of years, particularly until network companies get given access or permission by Bayes and Ofgem to access the data, to access disaggregated data in particular, we're really going to struggle. Because aggregated data is like a really rubbish sensor. Because there's very few substations that have 100% smart meter coverage, which means all that you're getting is a blob of usage that you can't attribute. So there's a few challenges in the short-term forecasting area.
Yep.
I think just also be useful going back to that transparency, where if that data on those particular nodes and assets that you're controlling and managing would also be available in terms of that real time, and you see the spike and you see actually how an asset's been used, that's also of equal value to those actors trying to join that network and saying, can they add value? Can they actually, you know, alleviate a problem, or are they contributing? Because at the moment, I know there's data that says it's either green, red, amber, green. But actually, that can mean a whole host of things. So as we move forward and more assets come on, that, you know, going back to that two-way transparency, and that's obviously part of the digitalisation strategies of a lot of the DSOs or DNOs, is to try and get that visibility. And I think that will help. That will help greatly in terms of people making the right decisions. So people like Philip, myself, can actually support our customers, and we're not just giving them a blind signal. We're giving them a signal that actually has an impact in the area.
Yep.
I think for me, there's a bit of a skills and capabilities thing where we need to bring into the sector. We should be going to like fast fashion and being like, guys, you guys are really good at working out what clothing sales are going to go over the weekend because the weather's hot. Come into the energy sector. But to do that, you're going to need to probably pay them a lot more than you do kind of the analysts in the energy sector.
Yeah, the fundamental part, I think that's possible, Alex. I think the fundamental part is about sharing the data and actually having all those players being able to actually access, like you talked about before, about open access, open APIs, that you can actually deal with this. Because for me, that's the foundation of anything that you do moving forward.
Alex, you'll like this. Talking about the fashion industry. Octopus has gone into the fashion industry.
Classy.
If you want Octopus socks, let me know. We're in another industry now. But anyway, joking aside, we've got about 3 or 4 minutes left. We're getting a reminder. I've just looked on the live chat session, and there aren't really any questions. There's one question about this is why leveraging reinforcement learning is key, but we haven't really got any other questions. So let's just kind of do everybody give it a quick kind of 30-second wrap up on what our view is of the importance of AI in how the grid is going to work into the future because of all of the changes that we've got going. Let me go around each in turn. I'll ask you all. Euan, final 30 seconds.
As I opened, it's critical, and as we put any devices or anything onto the network from a supply point of view, we have to get visibility control and then optimization of it, and therefore that optimization will only come through AI, machine learning, so it's a critical aspect in the future energy transition.
Right, I'm going around in order on this. So Alex, you're next on the list on the screen as I see you. You can't repeat what Euan's just said.
I guess for me, I see AI and ML as a way to deliver things cheaper in the short term over the next few years, which you can pass through to customers. But longer term, it's about, as more information comes online, improving that modeling and making smarter decisions.
Yep. Ronald?
I think the actual AI and machine learning that can be built inherently into the IoT devices that are coming down, computers coming down, the cost is coming down, and therefore the simulation and trying to predict what will happen will vastly improve and vastly reduce the cost of actually doing this, which will help effectively our end consumer.
Good, thank you. Thierry?
Well, for me, I see if we want to build an automation system for efficiently operating and managing the life cycle of that electricity or energy system, that we need at least 2 layers. There's a layer in which we model the system to a certain level of degree of accuracy. Therefore, machine learning is an essential tool. And then we have a layer of IoT, which captures the reality from the real world and ingests it into that model in order to kind of replicates that model in a virtual environment. And that then drives the automation algorithms for either operation or for lifecycle management.
And Leonardo, from a gas perspective.
Yep. I mean, there are several benefits, as my colleague said. Also in the gas, I mean, it might look strange, but we have renewables integration issues like biomethane, for instance. And just to make you then an example, AI is crucial to avoid failures in our network. And if we avoid failures, we are able to host more renewable gases, because if you host renewable gases, you need to pump the gas in a different direction, where the usual direction, right? So for us, avoiding issues in our pumping solutions is a way to maximize renewable integration, renewable gases in this case, of course, but it's still renewable and go towards the decarbonization of the system. So it's a clear benefit for the decarbonization of the energy community.
Excellent. Well, it's been a pleasure actually having a really good chat and conversation about everything around AI, machine learning, IoT, all the challenges, how the grid technology is changing, and all the kind of potential. I think we're all kind of thunderously agreeing this is what is going to happen and what we need and what we're actually all working on. So I'd like to just thank you all very much, and to Adam and the host for giving us a chance to have a really good conversation. Thank you very much.
Thank you.
Thank you.
Thank you.